Hello everyone, my project is the mobile AI image classifier for the design and development of AI applications for specifically of mobile. Our core focus is on creating powerful AI that can run efficiently on devices like your smartphone. The problem is simple. Standard deep learning models are too slow and too big for mobile phones. We need efficient AI. My system solved this by identifying animals in a way that's fast enough for a real-time mobile camera. I use 800 images per class to build a robust dataset. The key is the AI tool itself. MobileNet V2. Traditional neural networks are slow because they filter and combine features in one complex step. MobileNet avoids this using a technique called depth-wise separable convolution. This splits the process into two much cheaper steps, filtering feature and then combining them. This drastically reduces the calculation needed, which is the secret to its efficiency. So now implementation. We didn't start from scratch. We used transfer learning with a MobileNet V2 model already trained on millions of ImageNet pictures. We performed two training phases in PyTorch. First, training just the final layer and then fine-tuning the last 10 features to specialize the model for our animals. Crucially, we use data augmentation like rotation and flipping images to make the model our robust and preventing it from guessing wrong. So execution of the code I will show using Jupyter Notebook. So in Jupyter Notebook, first code blocks, we first loaded the pre-trained MobileNet V2 model and freeze the first layer so it does not causes any issue in the first layer which is trained on the millions of images. Then we modifying the last images. So here you can see that we have downloaded the MobileNet pre-trained model. So now we will need to gather the dataset. For gathering the dataset, we have used the Pexels API key, and using Pexels API key, we will download three type of images: dog, cats, and cow. Per class, will have 800 images, and this code will create the folder structure and required splitting of the images. So as you can see here in folder structure, he made the folder structure. He downloaded the images and 640 images for training, 160 value for each class. So here is the training of the mobile net. So here as you can see we have trained the model for 10 epochs. So now we will test the class. So for testing it, here you can see I have upload the image for the cow. If you upload and run, it predicted the class 97%, which we can show that it's working. Now I will show you why it will be favorable for the mobile. So as you can see for mobile, my model works for 326 million computational cost, while older papers used to work 560 million, which is double, and before that efficient, which is 153, which is 47 times. So parameter size is 2.23 million. Previous used to work on 4.2 million, and before that 138 million, which is 62 times. So conclusion is mobile use computer is approximately 47% lower than V6 hardware, directly providing its ability for resource trained mobile or embedded, fulfilling the project's requirement for efficiency. That's what I shown in this slide. So here you can see the same here since are directly correlated. So conclusion is that we successfully designed an AI solution based on the principles of IEEE MobileNet paper, resulting in a high performing classifier ready for deployment on any resource constrained platform. Thank you.